Hello guys, little update here. I'm about to fill the system with refrigerant. I have to do some modifications. Put the filter dry upside, like right up, right side up. I don't know, something like that. You know what I mean. It's not good if it's laying down. And I added a pressure switch. This is important, high pressure switch, just in case something goes wrong, so it turns off the compressor. I already prepared everything, so we have a bucket of warm water simulating. This will be used to cool down, for example, water for a induction heater or something. So we have warm water, 45°C. Really, I don't have any refrigerant at the moment. We have pulled the vacuum. It was a very long time for standing vacuum, so there is no leaks, I would say. We have temperature on the before the capillary, like after the filter dryer, and we have one at the suction line. Refrigerant is R290 or propane. It is a compressor that's designed for R290, so it should be all safe. We have a power meter connected that will be data logging, so you can see that the compressor will need power, like how much power it will need. Yeah, I managed to make the RS485 work on the meter with a converter to the laptop. So I'm very busy always. I will now set up the camera different so that you can see the entire thing, and I will start to fill the refrigerant R290 propane. Yeah, I think I showed everything. Oh yeah, I have to prepare one more thing actually. I have to put like a little pump into the water so it mixes the water. I forget that. I'll do this just now and then I will fill the refrigerant. See you soon again. I think we have now filled enough refrigerant. We are running about, you can see the pressures here. Hope you can see that read, should I say. Don't want to add more. Not that more. We have about 22 on the suction in the moment, 22.8 on the suction line, and 40 C about on the after the filter dryer. And pressure is on the low side. It is 2.5 bar suction pressure, and 15 bar on the discharge from the compressor. And we're running a clear side glass. Hope you can see it. It's a bit dark, but it's clear. And no liquid refrigerant is going back to the compressor. I lit one so I can see that. Usually you don't have them in the suction, but just wanted to see if there is any liquid refrigerant going back. Oh, and that just turned off, of course. Stupid auto shut off, sorry. Water is now about 18 C, 17.9. Yeah, I think it's stable now. Compressor dome temperature rate about 52 on the compressor dome or head. Sorry about that. I have allergies, so it's kind of annoying. I'm sorry for my voice, it's not the best. I think it's running stable now. Compressor needs 564 watt in the moment. That's within specification. I think it can do up to 600, but you have to also encounter that the fan motor is needing some 35 watts of that. It's because it's connected together with the compressor. And yeah, I'm going to let it run, and I put the camera back on the stand and you can watch until I have a very low temperature, at which point I will stop the compressor so that we don't get a liquid refrigerant going back to the compressor. That's not good. system is now running stable and water temperature is still dropping, so I guess I will end it here now. Video is already like 33 minutes or so. Yeah, thanks for watching and see you soon again. I will stop the compressor and stop the video. Thanks for watching and see you soon again. Bye. Let's go quickly over the theory of refrigeration systems. So you have your hot side, your cold side of course, condenser and evaporator. You have the compressor, it's increasing the pressure, then the vapor refrigerant condenses in the condenser and gets to the capillary in this case, but it could be expansion valve, electronic expansion valve and so on. This is a restriction. Now this side is high pressure, high temperature, and then right before the like the expansion valve or capillary, we use of pure liquid refrigerant, so it needs to be subcooled, right? Then we going through the metering device and entering the evaporator where it evaporates, and it going back to the compressor. It needs to be like superheated a little bit so that we don't have liquid refrigerant going into the compressor. That's the most basic explanation. If you want a more detailed explanation, you can either Google it or could make a separate video about this. But now we're going to calculate the power of the system, of that what you just see running. Water has a specific heat of 4184 joules per kilogram Celsius, so and one watt is 1 joule per second. So first I must make two tests. first test we was using 10.6 liters of H2O water at 35 bar. Sorry, I ran out of memory. Where I was? So we have 10.6 liters of H2O at 35.5 C to 9.5 C in 20 minutes. So we used the formula. I would explain this formula and so on if someone is interested, or just Google it. We get to 960 watts of output power, and the second experiment we have 10 liters water and we changed 19.7 C, and that's 915 watt, and it was 15-minute long experiment. If anyone has questions, I could explain them. The system was about 1 kilowatt. I was testing. It depends, like about 1 kilowatt you can expect if the water temperature is in the beginning higher, like let's say 40-45 C. We can extract more energy faster, so we get like 1000 watt or 1000 and something watt. So you can say it's about a kilowatt of heat cooling capacity. What is about the limit of the compressor? As you see in the datasheet, it says about maximum is 1 kilowatt, I think. Yeah, thanks for watching, and yeah, see you soon again. Just let's go quickly over the things here. I was recorded the previous video before the test of the bucket of water for cooling a few days ago. So let's go quickly over the setup. We have the compressor, we have a liquid dryer, we have a sight glass, we have a suction sight glass. Usually you don't have that one. We have the condenser, we have a high pressure switch. I did change from the first video the power cord. I put a longer power cord on, and I used this 4 amp motor protector for the start and stop of the compressor. Set to 3.5 amps. I may increase this a little bit, like 3.7 maybe. And we have the evaporator in there and the pump for mixing the water. That's all.